Today we are doing 12.1, which is piecewise functions. So a piecewise function is a function that is defined by different formulas or functions for each given interval of the domain. Okay, so a function that is defined by pieces of functions for each part of the domain. So for example, okay, so what we see here is that there are three sections of the domain, right? So for when x is greater than 0, when x is equal to 0, and when x is less than 0. And for each section of that, there is a function that is like basically for that section of the domain. So I like to kind of think about it as like there are three functions for the three windows of the domain. Okay, so I like to kind of think about that as a window, like that each little section, the way when I graph them, I kind of will draw like little sections of my graph so I can sort of see like, okay, in this part of the window and in this next window, so you'll hear me kind of talk about windows. Okay, so for this is an example of a piecewise function because it's defined uniquely for three different intervals. Okay, so like again, 2x for this section, 1 for this section, and then negative 2x for this section. Okay, so creating a piecewise function, this is when we're going to like write the function and we can graph it. So we're given a chart. We have the weight per pound and the price per pound. So whenever we have the weight, right, you can see that these are on intervals. Okay, so this right here is our domain. These are the values of the x's. Okay, so these are going to be like our x intervals. And then these are the range or the values of y. Or sometimes, like in this case, these are the y values because they're not exactly equations, right? It's just it's a number. Okay, so then if we're going to write a piecewise function, the first thing that I usually like to do is, so I write that f of x, and then I give myself that big bracket. Now, honestly, the first place I usually start is I start with the three, like my domain. I like to figure out like what are the different windows I'm talking about. Okay, so what we're looking at here is over here, we kind of are talking about the weight. Okay, and then over here, we're talking about that like price per pound. All right, so the first window that we're looking at is from 0 to 1.99. Okay, now when you're writing this, we're gonna write these as inequalities. So if, and then we're gonna say our smallest number, x. Now, I could say 1.99, but that's like almost to 2. So if I say 2 and then I just don't include the 2, I'm saying less than 2. So 1.99 is less than 2. And then I would say greater than or equal to. So if we put them smallest number, x, biggest number, our arrows will always point to the left for our inequality. Okay, so then for the next little window, we're looking at from 2 to 4.99. Well, again, that's like from 2 to almost 5. So we could say 2x 5. And then, again, we won't include the 5. We'll just say less than 5. But then this time it starts at 2, so we'll say greater than or equal to. So x is greater than or equal to 2, but it's less than 5. Okay, and then our last window is when x is 5 or more. So that is if x is greater than or equal to 5. All right, now here we don't have equations. Like up here we had equations with x's. Here we just have constants. So, excuse me, the price per pound at that first window is $8. The price per pound at the second window is $6. Excuse me, and the price per pound for my third window is $5. All right, so now, like I said, what I like to do, and you don't have to like draw these little, excuse me, the lines on the graph, but to me, it helps me kind of figure out these different sections of my graph. Okay, so I'm going to draw just a little dotted line right there at 2. And then I'm going to draw a little dotted line at 5. And so it's kind of like, here is that window 1. Oops. Here is that second window. And then finally, this is my window 3. Okay, and again, you don't have to label that. This is all just to kind of help us get this to the graph. Okay, so from 0 until I get up to 2, I'm at 8. So I'm going to do a closed point at 8. This is just a constant, so it's going to be a horizontal line. But then when I get to 2, it's not equal to, so I have to have an open point there. All right, and then from 2 to 5, I'm at 6. So again, it's equal to at 2, so I'm going to put a point there. And I draw that horizontal line until I get over to 5. And then again, I leave it open at 5 because it's not equal to the 5. Remember, we went up to 499, so less than 5. And then at 5, I'm going to start a closed point, and then I just go out horizontally that way. And I'll draw an arrow because it says greater than 5, so it's all the x's greater than 5. So we put that arrow. All right, so the next section is evaluating the piecewise function. So each piecewise function, we're going to evaluate it for these 2 different values. So we know function notation, right? What this is saying is that we are going to plug in that -2 value if there's an x for us to plug it into. So the first part of this is sort of, we need to find the window that it fits in. So find the window the x fits in, and use that equation. Okay, so when we're looking at -2, well, where does -2 go? Well, -2 is going to go in this section because -2 is less than 0. And then if we want to do f of 5, where does 5 go? Well, 5 is greater than 3, so 5 has got to use that third window. All right, so we use function notation, so f of -2. So when we go, there's nowhere to plug in the x, so we just give that constant value. Okay, so f of -2 is just equal to the value -5, because that was the y value for that input. All right, and then we do f of 5, same thing. There is no place to plug in an x there, so it's just that y value. Okay, so that's the evaluating it for that function. So then when we look over here, we're still doing the same 2 x's, right, the same inputs. So we look and we say, okay, well, where does the -2 go? Well, the -2 would go into this equation, and the 5 would be in that window. All right, so now this we are able to plug in. So we're going to actually plug in and say, okay, f of -2, we know that that means that we plug in -2 for x. So we have 3 times -2 plus 4. That gives me -6 plus 4. So f of -2, -6 plus 4 is -2. All right, now again, we have to use the other equation for the 5 because that's where it's equal to 5. So we're going to do f of 5, and we're going to use that other equation. So I have 5 squared minus 3. That is 25 minus 3. So f of 5 is 22. Okay, so again, evaluating a function, evaluating a function, it's just like evaluating all the other functions we've done this year, but you just have to make sure you're plugging it into the right equation. So figure out which window the values go in and then use that equation for that expression. All right, looking at the back. Okay, so now we're going to graph them. So a few things that we need to pay attention to is when we are graphing, we've got that greater than or equal to, less than or equal to. Those two, remember, these are going to be a closed point at that end, right? So like your interval has different, sometimes it's an equal to, so you would close the point at that point. Sometimes it's not, and so it would be open, okay? And so we'll kind of talk through this as we go. So a couple just reminders that I'd like to give you is that make sure that we're doing that like y equals mx plus b. Some of them won't be linear, but for the most part, we're kind of going back to that graphing form. So where we have m is our slope and b is our y-intercept. So the question kind of comes in a second, and you'll see as we get into this, I just kind of wanted to write a note about it first, is if we're like ever trying to plot something on our graph, like if we're, trying to do, x plus 3 right here, but notice this is when we have a y-intercept of 3, but this is for when the graph is like to the right of the y-intercept. So like, how am I going to plot the y-intercept if I can't plot it, because it's not in that window? So it's like, I'm going to kind of write us a little question here. So it says, where do you plot if you can't use the y-intercept? Okay, and again, it'll make a little bit more sense as we get into an example. So where do you plot if you can't use the y-intercept? So you're going to use the values in the domain to find points. Okay, and you're going to see me do this in just a second. Okay, so, all right, so for example, number 4. So we have 2 windows. Okay, so we have kind of window 1 is when we are less than 2, and window 2 is when we're greater than or equal to 2. So that means over here, I'm going to kind of draw in that little dotted line over here for myself at 2. All right, so now I look and I say, okay, I'm going to draw this first one. I have access to the y-intercept. So I'm going to bring it down and I say, okay, what's the m and what's the b? Well, the m is that coefficient on x, so it's -3. And remember, if there's nothing added or subtracted, then that means our b is 0. Okay, so that means we're going to just go right here to the intercept at 0, and then we're going to plot a slope of -3. So rise 3 in the negative direction, rise 3 in the negative direction. Now I'm also going to go back this way and pay attention. When I get to 2, that point is going to have to be open because this graph is not equal to 2, it's less than 2. So as I keep going and doing my slope down, now when I get here, this point is going to be open. And so now I can graph that left side of the equation in window 1. And then I look at my second equation and I say, okay, well, this is when my slope is 1 and my b is 3. Well, the problem is that I can't graph anything in this section of the window, right? In this window 1, because this graph is for window 2. So I don't have access to that y-intercept. So what I do is I'm going to plug in this first value of the domain, and I'm going to say, okay, well, what would f of 2 be? Well, that would be 2 plus 3, which is 5. So then I can plot the point 2, 5, and then do my rise and run from there. Okay, so plot that 2, 5 point. So I'm going to go to 2, 5. Now, in this window, it's equal to, so when I get to that point, I'm going to draw an actual point, not an open point. And then I have a slope of 1, so I'm just going to rise 1, run 1, rise 1, run 1, rise 1, run 1, and then I can connect those points. And there's the graph for window 2. So we have this function in 2 pieces because there were 2 intervals in the domain. Okay, now our next one, this one is in 3 intervals. Excuse me. So I'm going to draw my little lines on my graph. So my first one's at -3. I'm going to draw a little dotted line at -3. Then my next interval goes from -3 to 1. So I'm going to draw a little line at 1. And then this is my third window over on the right side. Now, excuse me, 2 of these are linear and 1 of them is quadratic. Okay, so for our quadratic, we won't have an m and a b, but we can just kind of make a t-chart for that one. All right, so again, when I look at this 3x plus 8, I know that my slope is 3 and my b is 8, but whenever I look at the window where I'm plotting it, I don't have access to the y-intercept or the y-axis to plot that b. So I'm going to do what we did over here, and I'm going to figure out what the point is that's going to be the point that we put there, and then I can just do my slope from there. So I'm going to plug in that -3. So f of -3 is 3 times -3 plus 8. That's -9 plus 8, which is -1. Okay, so this is the point -3, -1. So again, I go back up and say, should that point be closed? Well, it's equal to at that point. So I'm going to go over to -3, -1, and I am going to draw in an actual point there, closed point, because it's equal to. So now I'm just going to do the slope from here. Now, normally we think positive slope, we'd go up and over, but I can't go to the right. I can't go in that window. So I'm going to just have to go down. So I'm going to go down 3 and to the left. Because remember, if I go down and to the left, that's negative, negative, which negative, negative is positive. So I'm going to go 1, 2, 3 over 1, and 1, 2, 3 over 1. And then I'm going to connect those points that way. Okay, and if you like that method, you could also do it where you plug in the points for -3 and 1, and then just plot the points on those two lines, and then connect those points like that. Or since we have access to the y-intercept here, we can just plot it with an m and a b. So here, my m is -2, and my b is 0. So I go to that 0, 0 point, and a -2 slope. That means that we're going to go up and to the left, up and to the left, up, and then pay attention here. It is not equal to, sorry, not equal to. So when we get here, this is going to be an open point. And then the same thing when we get to the 1. When we go down 2 and over 1, this is also going to be an open point. So that's the graph in my second window. And now, excuse me, I'm going to just make a T-chart for this because it's not linear. It doesn't have a slope. And so I'm going to kind of need to know, like, what are some of the values for that? So I'm going to plug in and just kind of make a chart. So if I've got, let's say, I'm going to say x, and then we'll put our equation in the middle, x squared minus 3, and then we'll have a y over here. So I'm going to start by plugging in my 1. So I get 1 squared minus 3. That's 1 minus 3. That's -2. So that's the point, 1, -2. Then I'm going to plug in the next number. Just go in line, 2. Excuse me. 2 squared minus 3. That's 4 minus 3, which is 1. So that's the point, 2, 1. I'm going to go ahead and give myself one more. 3, so that's 3 squared minus 3. That's 9 minus 3, which is 6, so it's the point 3, 6. All right, so now I'm just going to go plot those points. Now this one, when I plot that 1 point, it's a closed point because it's actually equal there. So when I go to 1, -2, now this is going to close the open point from the other graph, but that's okay. Excuse me, my allergies are killing me. So I'm going to close that point, but then I just keep on plotting. 2, 1, and 3, 6. And then connect them. Sorry guys, I've got choked up. Okay, so again, we have 1, 2, 3 windows, 1, 2, 3, and we have a different function at each one. The only thing I was going to say of this last one is, you want to make this one look kind of curved because it is a quadratic, and we know it's part of a parabola somewhere. Okay, so we kind of just curve that up a little bit. Okay, our last example is writing our own piecewise function based on a graph. Okay, so I lost my pen. There we go. All right, so we see that we have 3 sections again. So I'm going to start by kind of figuring out where those windows are. and starting with that. So we're going to start by writing our f of x equals, and we're going to give ourselves kind of a big bracket. And so we're going to go over here and we're going to start by defining the intervals that we're going to look at. Okay, so our first one is if x, and we look at that and we say, okay, it's -3 and it's less than -3. So again, it's not equal to, so it would just be if x is less than -3. Then our next interval is between -3 and 2. So again, I write it out by saying smallest number, x, largest number, then my arrows always point to the left. So which one is closed? This one is closed at the -3, so I would have an equal to there, but it was open at the 2, so I just have a less than there. Okay, and then finally, our last interval is we start at 2 and we go to the right, so that is when x closed point is greater than or equal to 2. Okay, so to me, that's kind of the easiest part, is like figuring out, okay, what are our little sections? All right, so then we're going to go back in and we're going to kind of look for counting that rise and run, looking for where the y-intercept is. Okay, now on these, we're going to break some rules because technically this graph should not go in here, but we're going to go ahead and like continue that slope so that we can see where it crosses the y-axis to find that b. Okay, so we have to find points. So I can see that like that's a point and that's a point. So I'm going to write m is equal to and b is equal to. So when we count that rise over run, we rise 1 and run 3. So our slope is 1/3. Okay, now we're getting ready to break rules because we're going to take this function that's not in the middle window, but we're going to just continue it up there so we can see where it crosses the axis. Okay, so we're going to rise 1 and run 1, 2, 3 because we're following that pattern. And so we can see that here the intercept would be 0. Okay, so remember when we're writing equations, we're using that y equals mx plus b. So here we have 1/3 x, and there's no plus b because it's just 0. Okay, now this middle section, it is excuse me. It is horizontal. So this is just a constant. So it's just gonna be, just a number. Okay, so we look and say, okay, what is the number there? Well, the y value is 2, so that's all we put there. There is no x with it because it's just a horizontal line. It's just y equals 2. All right, and then our last one, we're going to go over here and we're going to see if we can find another point. So we go up, rise 2, and it looks like right there, rise 2, run 1. Okay, so that means over here our slope is 2. And then we're going to cheat just like we did earlier and kind of go back into this other window to see where the b is. So we go down 2 over 1, down 2 over 1, and it hits at that 2. So my b is 2. So if my m is 2 and my b is 2, this gives me the equation 2x plus 2. And that is it.